Now, questions over how to do, we are going to put problem number 10 will be the last thing if we get time to do it. So I'm not going to spend my time on that one, and we got other ones that one. Other ones besides 10. If we run out of time, we do 10. Don't worry about that one later. Mitch,
What was the, what would be the fraction form of
what?
mercury?
They ask you for percent, does it not?
Yeah, or down.
112. Okay. 5 over 60. 112. Lady Gates.
I think we're on the floor.
Problem number 4. El número el cuatro. Once again, it seems we struggle with these greatly. If you look at this, factor 2x squared plus 3x, you are trying to do reverse distributive property. What do both of these terms have in common? Well, number-wise, they don't have anything, because you can't take anything out of both 2 and 3. There's no common factors there. But here you have an x squared and an x. What do they both have? They both have an x. Okay. You can't take an x squared out because that one doesn't have an x squared. So if you take an x out, divide x squared by x, what are you left over here? A 2 and 1 dx's. If you take an x out of this, the x's are gone, you just have a 3. If I remultiply this, x times 2x is 2x squared, x times 3 is 3x, I get what I started with. And that's the basic gist of distributive property. Factoring out, expanding back. What did you have?
5x.
Where's a 5? You can't take the 5 out. And that's what I write in my notes. I'd say, ask yourself, what do they have in common? What can you remove out? There's no 5s. What factors do they have? That's it, one question? Love it. Josh,
I think we're number 1.
number what?
1.
Number 1. Three out of 4 doctors say they recommended the product. 60 doctors surveyed did not recommend the product. This is a ratio problem. Did you draw a ratio box, Josh? All right, what am I comparing? Your ratio box is made up of, first of all, total. I am comparing doctors that recommended and the doctors that did not recommend. So filling in my ratio here, if it says 3 out of 4 doctors survey recommended it, Josh, how many doctors recommended it in that ratio? If 3 out of 4 did? What's that?
Wait, what?
How many doctors recommended it? If 3 out of 4 doctors recommended it, how many doctors recommended it?
6.
No, I'm looking at the ratio part. That's the actual numbers. 3 out of 4 is what I'm looking at right now. If 3 out of 4 doctors recommended it, what's my ratio? No, 3 out of a total of 4. 3. 3 recommended it out of a total of 4. Doesn't it say 3 out of 4 recommended it? Where does the 1 go? 1 is how many would not recommend it, right? Just like if 3 out of 4 people were girls, 3 girls out of 4 people, 1 would be boy. That's my ratio, and then I just have to fill in what were the real numbers. Well, they either tell me how many recommended it, how many did not recommend it, or how many total. Which one do they tell me? What is 60? 60 doctors did not recommend. So that goes with the did not recommend is 60. And then they're either going to ask me how many did recommend, or they're going to ask me how many total doctors were surveyed. And it asked me what? How many were surveyed. So this is the one you want. You don't need this. You needed it to find out that number 1, but after that you don't need it. How does this work then? How do I go from 1 to 60? You multiply by 60, so 4 times 60 is 240. If you have to do that off to the side, go ahead and do it. 1/4 equals 60 over what number? 1 times 60, 4 times 60. But it sounds like you're getting the ratios and the real numbers confused. Ratio goes here, that's the fractional part. Real is what really happened. Keep!
I need your number 17.
Number 17. Is that over here somewhere? 16. 17. Somebody division by order of division of scientific notations. When you see this, see, in math, certain things should pop in your head. When I see this, I automatically know probably if you went wrong, what you did wrong. Drew, what pops in your head when you see this?
Negative exponent.
Alright, and what does that negative exponent, what's the deal when it's division by scientific notation? What's different than that than multiplication? When I see the division of scientific notation, the first thing, well, obviously, you have to divide this out. That goes without saying. 2 goes into 1.2.6 times, right? 1.2 divided by 2 is 0.6. And then I have times 10. Here's where the sticky part comes in. What happens to these exponents in division when it's this divided by that? Elijah? You subtract the bottom from the top. It is the 5 minus this. And here's where those of you that like to cut corners get things goofy. It is 5 minus a negative 2. 5 minus whatever this was, which was a negative 2. Well, 5 minus a negative 2 is really 5 plus 2, because 2 negatives next to each other is addition. So this actually ends up being 7. And unfortunately, that's not the right answer yet either. Why, Riley?
Because
Because it's not in scientific notation no more. If I can use a double negative. Grace, what do I have to do to make it in scientific notation?
the decimal.
I need to move this decimal on the other side of the 6, which means I made this one bigger. I have to make this one smaller to balance it out, and you end up with 6 times 10 to the 6th power. Now there's a plethora of things that you could write yourself notes for on this one. The number one, how many people missed it because of that exponent there? Subtracting a negative is adding. If this one's negative, you're actually going to end up adding it because you do the opposite of it. So that's when I let you use those notes.
You see, Ron, can you do his hands?
I'm sorry, what?
I will be right back. May I use your restroom, please?
Why?
He's bleeding everywhere.
Why are you, from what?
Skin peeled.
Is it peeled on its own? Other questions while we're here? Brianna, number 19. Number 19. Well, how do you simplify square roots? Rule number 1, Cameron?
Do it out.
Well, we call it prime factorize them. Which means you have to do the tree thing in. What times what gives you 3,600? Well, the logical one is 36 times 100. What times what gives you 36? Square root of 6 times the square root of 6. What is 100? Square root of 10 times the square root of 10. 6 is the square root of 3 times the square root of 2. Square root of 3 times the square root of 2. 10 is the square root of 2 times the square root of 5. And square root of 2 times the square root of 5. Here are all of your things. What's the rule? If you see 2 identical ones, they go away to give you a normal number. So 3 and a 3 gives me a normal 3. Square root of 2 and the square root of 2 gives me a regular 2. Square root of 2 and the square root of 2 gives me another regular 2. And the square root of 5 and the square root of 5 gives me another 5. All my square roots have crossed out, lucky me. 4 times 5 is 20, 20 times 3 is 60. No square roots are left because 60 3,600 is actually a perfect square. O'Reilly.
18.
18. Do we have problems with the number part of this, Riley? Like 24 over 16 reduces to what? What number goes into 24 and 16?
8.
8. So if you divide 16 by 8, you get 2. Divide 24 by 8, you get 3. Everybody's good with that? Now what about the letters?
You move the negative exponent down
Okay, which makes it
from y to the
y to the first power. Okay, and if it's on the bottom, what is a y squared and y to the first? Y to the third. Now what do I do about this? I have x to the third on top and x squared on bottom. Okay, they're both positive, so that's okay. That means you have 3 x's times themselves on top and 2 x's times themselves on bottom. Which means they're identical. One x cross off with another x, the second x cross off with the second x. Left with one x that didn't cross off, and these stay on top. 3x has to stay on top, 2y cubed stays on bottom. That's all you can do with it. You can have a fraction as long as the exponents are positive. Question about this one?
yeah. Is that a negative one?
This was a negative one. They brought it down here, became a positive one. Winkling.
Height and villain.
Wait, but I got a question. If that negative, if you bring that negative down, then why would that be -3? I mean, y equals -3.
I brought this y to the negative 1 down, it became y to the positive 1, which combined with the y to the 2 plus another y to the first, giving y to the third. Y times y times y. Y to the third. Winkman, what one is it again? 11, right? All the way on the top. Use how many unimultipliers? 2 to convert 54 square feet to square yards. Anybody, why do I need 2 to do that? Isabel? Right, because of this right here. What is square feet? Square feet is feet times feet. If you're a Dr. Seuss fan, you know what that means. Feet times feet. Oh, the feet you need. This is 54 square feet. It's not 54 squared. The feet are what's squared, not the 54. So you need a unit multiplier to cross each of those labels feet off with. And I'm changing feet into yards, so that's the other label I need. And hopefully you know how many feet are in a yard, which happens to be 3. Your label feet cross off. Get the blue to go. I am left with yard times yard, which is what it wanted, yard squared. And now your numbers are 54 is on top, 3 times 3 is on bottom. What is 54 divided by 9? 6 yards squared.
So you're just trying to cross off the labels, or
Have I never said that before?
no, I meant like if you're just crossing off the labels, you don't cross out the numbers either, since it goes from 3 feet. 3 feet.
Number 1, yes, labels are the most important thing when it comes to unit multipliers. And number 2, yeah. I mean, numbers, there's 54 on top, 9 on the bottom, and then you simplify your numbers. Labels are important. Pretty sure that was part of the spiel. Labels, labels, labels. Mitch!
Number 10.
Is that on this page? That's on the next page. All the way down at the bottom. Life size, bottom 10. Wait, was 10 the one that I said don't worry about?
Yeah.
Yeah, we're not gonna, I may ixnay 10 from the whole test. I'd rather go about the other stuff if that's possible. If nobody has any other questions, then I will do 10, but otherwise I'm leaving. The amount of time it takes me to explain 10 far outweighs any benefit it'll have. I might just say, let's not do 10. John?
I do number 6.
Number 6. Right here. No, it's over here. Number 6. Number 6. Find the area of parallelogram ABCD. Well, the first thing I suppose I would do is I would highlight that. A, B, C, D. Then I would write the formula for the area of a parallelogram, which is what? JD. This is where we would go wrong. Area of a parallelogram is different than the area of a rectangle. Area of a rectangle, we always go length times width. You can't use that with a parallelogram because there's really no width there per se. A parallelogram is, Riley? We use the word base times height, and we use those letters because when we say base and height in math, those ones have to be the lines that form the right angle. This is the point. I would look for a small little tiny square that they put on between two lines, and oh look, once they give you this, you know your base and your height because they're the two lines that make the square. This one and this one. 12 times 12 is going to be my area, which is 144 inches squared. Same thing for 7 while we're here. I'm guessing 7 asks you for area of the trapezoid. And this is why you have your notes. A trapezoid is, area is 1/2 base sub 1 plus base sub 2 times the height. Again, you see the B's and the H's. So you know the right angles have to be there. The height is the same as it was before, it's 12. What are my bases? We talked about this before. Bases, when you talk about parallel or trapezoids, are the two parallel lines. So if you go back up here and look for the parallel lines, it's this 12 and this all the way, 12 plus 10. So it's 12 and 22. 12 plus 22. Two parallel lines, 12 and 22. Mitch, you got that? You go up there again and show you where 12 and 22 come from?
Okay.
You do want me to go back up there and show you? Here's my parallelogram. Erase. Let me erase. The two bases are the parallel lines. This line and this line are parallel. What are the lengths? Well, one is 12 from here to here. The other one from here to here is 12 plus 10, 22. And please note, children, because of order of operations, you have to do this parenthesis first. Well, there's some other things you can do, but it's just smart to do that. This is 34. Now it doesn't matter what order you do, because multiplication can be done in any order. Half of 12 is 6. I would take 34 times 6. 24, 218, 204 inches squared. Likewise for the triangle, I write my formula for a triangle. Area of a triangle is 1/2. Oh look, base and height again. But it's only the base and height of the triangle, not of the whole thing. So we go back to our original sheet up here. We are looking only at the triangle this time. And the triangle, the base and the height. Look for the little square thing there. Things that form the right angles. And 1/2 of 10 times 12. 1/2 of 10 times 12. Any order operations anyway, 1/2 of 10 is 5. 5 times 12 is 60. Those those should be relatively easy for you. And while we're standing here for problem number 9, please understand this, okay? If you're looking for direct variation and they give you the equation in what form is this? After all these years, slope-intercept form, okay? Direct variation has to cross through the origin, which I missed a little bit with. So that means if you're given an equation in slope-intercept form, what does this number always have to be? Where does it cross the y-axis? That's 0. Okay? If there's any number out here besides 0, this cannot be direct variation. Because you'll end up crossing the y-axis at any other point than the origin. So if there is a 0 there, then it's going to be direct variation. If there's no 0 there, I mean, if there's some other number besides 0 or not, if there's nothing there at all, that's okay, because that is 0. Oh, that was 6. Good point all the way around. We're on to number 10. I think we'll get to number 10. Keith, maybe I'll make 10 extra credit. That would be better.
Yes, how much?
Which one? Keith says, can we do number 3? 5 minutes is what percent of an hour? So here's the deal. 5 minutes is what percent of 1 hour? Or what, you can start with making it a fraction. 5 minutes is what fraction of an hour? Well, the problem with this is minutes, this is hours. How many minutes is an hour? 60, so you've got 5 over 60. That's what fraction reduces down to 1/12. And that's still not in percent form. How am I going to change the percent form? Here's what I write down to note myself. 1/12 times 100% will tell you what percent that is. Which in essence just means you're going to do what? Divide 12 into 100. Because you get 100 over 12. You divide 12 into 100, that'll tell you your percent. Which happens to be 8, 960. Remainder of 4/12, which we change to 1/3 of a percent. You could make a ratio box, you'll still get the same thing. 1/12 is what number over 100? You'll still get 8 and 1/3. Either way, it works. Brian, did we do 2 already? A used car salesman purchases a car for $4,000 and sold it for 40% more. What was the selling price of the car? How do we go about doing this? This is a percent increase. Anytime you're adding percentages, you need to do this. You start off with your original price plus whatever the increase is, and then you have your final price. What were my percentages? Well, original is always 100. How much am I increasing it? 40% more. So my final percent is 100 plus 40 is 140%. And just like that ratio thing we did before, here's where we put the actual numbers. Which of those 3 does the problem give me? Does it tell me what the original price of the car was? Does it tell me how much the increase was? Or does it tell me the final price of the car? I honestly don't remember. Mandy Roth? A salesman purchased the car for $4,000, yes. And then you have to decide, are they asking you for how much the increase is or how much the final price is going to be? What is the selling price? So you don't need this 40. 100 over 140 equals 4,000 over what number? Quickest way to do that, anybody? could do cross products and divide. Jaden, shoot, what would you do? Or Jaden. Is that the way you do it? You multiply this times this and divide by that? Sure. 100n equals 4,000 times 140. 1, 2, 3, 4 zeros. And 4 times 14 is 56. Divide by 100. Divide by 100, and you end up with $5,600. Anybody else done it some other way? You could have, Keith,
Reduce.
made that 10 over 14. And then what? You guys go about the hard way there. Elijah, what would you do? I'm saying you could do it, but how would you? 10 times 40 is that, so 40 times that. You could have left that as 100. 100 times, wait, you would have done 10 times 400, right? 100 times 40 is that, so 40 times that. Any way you want to do it is fine, but some of you, sometimes reducing all the way makes it a little more harder numbers. More! Oh, we still have one? Mitch? Number 5. Did I do 5 already? You sure? During the season, a basketball player made 24 out of 40 free throws. What is the probability he will make the next free throw? Well, this is it. 24 out of 40, that is your probability. Just reduce it. 8 goes into both of them. 3/5. That's experimental probability. Does it actually happen? You just reduce it, and that's your probability. Now, if they ask your probability he won't make the next one, it would be the opposite of that, 2/5, but they ask for it. Mr. Fisher? 14. Did we do 14 already? Is that on this sheet?
Somewhere. Another side.
It is on the other side. Sometimes you can't see the forest through the trees. This figure illustrates, is this the wrong one?
No.
What's your question on this one? I probably actually would ixnay this one. Does it really look like the area of a triangle? Remember a triangle, prism? I'll probably, I don't know, we'll see what tomorrow's test is. I'm not sure what you do for that. We probably haven't talked about it, have we? It's what? Yeah. It doesn't look, it wouldn't make a triangle prism. You can rule this one out.
We have ones that,
Yeah.
we have a paper that shows.
Oh, here, yeah. Refer to notes. There, you have that paper out in case they ask you the same question tomorrow. Cameron Colbert.
How did you get
How did I get who?
1/3%? So what the percent part of that?
Well, when I do my fraction, my remainder is 4, so I make a fraction out of it. 4/12 reduces down to 1/3. Sure.
Page number 16.
15. You must be getting close to the end, right? Right up here? Yes. It is up there. Oh, yeah. Anybody, this one? This is like a complex equation. The first step when you see this is you need to make sure that each side of the equal sign is simplified, which means put together any like terms you can. Okay, well, obviously you can't do anything with 7 because it's all by itself, but what can I put together over here? I've got an x and an x. If I have 4 x's and I subtract an x or take an x away, what am I left with? 3 x's. And then I have that minus 5. Now, each side is simplified. I use the rules for equations. I want to get x by itself, so I have to do 2 things. I got to get rid of this minus 5. I got to get rid of that 3. Always, always, always do the adding and subtracting thing first. Opposite of subtracting 5 is adding 5. Now I get 3x equals 7 plus 5 is 12. Last step is always division part. X equals 4. Mitch,
What's the difference between x squared and 2x?
x squared is x times x. X 2x is what you get when you have x plus x. You have two x's here. X squared, x times x is x squared. Wow. Cole quit. Organization, my friend. We got more papers coming all over. See, that's why if I'm taking notes, I take a piece of homework paper because they're already split into nice squares and I just know exactly where my notes exactly are, you know what I'm saying? Then you're not searching all over for all sorts of things. 16. 16, I'm guessing the best way to do this, I mean, you could reduce this fraction, this is actually 2.8 is half of that, so it would be 2 over 1, but rather than that, I would just say this, cross multiply. 2.8 times x has to equal 4 times 5.6. 4 times 5.6 is 22.4. And then you just divide by 2.8. 22.4 divided by 2.8. Move the decimal out, move the decimal out. How many times does 28 go into that? 8 times. Aubrey, first time today. I've had a bell ring.
Number 13.
Did we do 13 right? No. How did we get away with not doing 13? Is that over here? And down here? Oh yeah, formula for. Okay, first of all, Aubrey, you don't need this. You just need to know that the letter N is what term you're looking for. And they told me I am looking for term number 50. So wherever there's an N, I put the number 50. So I've got this formula they gave me. So wherever you see an N, you put the number 50. So this a to the 50th term, or the value of the 50th term, equals 2 times 50 minus 1. And 2 times 50 is 100. 100 minus 1 is 99. This is just a label. The 50th, the value of the 50th term is 99. I thought that was refreshing. I'm physically drained. Brooklyn, anything? All of your questions have been answered? All quick. Does it take you long? Because I can answer Rich's while you're looking.
20.
Huh?
20.
Did you prime factorize this?
Yeah.
And what'd you get?
3 square root of 2. I meant 3 times the square root of 2.
Well, that doesn't give you
That's
18.
the answer.
Oh, I meant 6 and 3.
So the square root of 6, sorry, square root of 6 times the square root of 3. But the square root of 6 can be broken down into the square root of 3 times the square root of 2. So you've got this and this that are the same. That gives you a normal 3, and the square root of 2 doesn't cross off with anything, so it's square root of 2. Mitch?
Should we go back over number 18?
What part, what do you need to see? What is bothering you on number 18? You understand how the numbers give you the numbers or the letters give you the letters?
the letters.
Alright, so you understand you divide both of those by 8.
Yeah.
And you end up with a 3 on top and a 2 on the bottom. Okay, do you understand that x cubed means you have x times x on top, x squared is x times x on the bottom. And one for one they will cross off. This x cross off with that x, this x cross off with that x, and you're left with one single x on top that doesn't cross off. So that x stays on top. Then we have to deal with the y's. I don't deal with negative exponents, so I change them to positive exponents by putting them on top to bottom or bottom to top. This one's on top, so I move it to the bottom, it becomes y to the first. When I put this together, this is y squared, y times y, times another y, how many y's is that on the bottom? So it's y to the third power.
So the y on the bottom and then the negative y on top, they both go down to the bottom.
The y squared was already on the bottom, it didn't go anywhere because it already had a positive exponent. The y on top comes down because I need to make that exponent positive. And then they can combine because it's 2 y's plus 1 y. You are looking for positive exponents, that's basically it, ones that will combine. You will never have the same letter on top and the same letter on bottom because they're always going to cross cancel with the positive. Otherwise, it will keep. Oh yeah, grab a test note out of the way. Go band people, go band people, go band people. Anything else? I don't think we have time to do number 10. But I probably will make it extra. Four sides of a square increased by a scale factor in the area of the larger square is what percent of the area of the square? Each time we got not enough. Not enough. Alright, I got a test note for you.